Oi. We are back again, but we will be coding today, and it will be this hard problem: maximum running time of n components. Let me check my voices. Okay, so let's read the problem statement. You have n computers. You are given the integer n. Okay, for n computers. Okay, and the n denotes the number of computers, and a zero indexed integer array batteries, where ith battery can run a computer for battery I minutes. You are interested in running all n computers simultaneously using the given batteries. Okay, so I want to run all the n computers simultaneously by plugging in the batteries, and the batteries will run at least batteries minute or exactly or battery minutes. Initially you can insert at most one battery into each computer. After that, any integer time moment, you can remove a battery from a computer and insert another battery any number of times. After that, at any integer time moment, you can remove a battery from a computer. Okay, you can remove and insert another battery any number of times. Okay, the inserted battery can be totally new battery or a battery from another computer. You may assume that removing and inserting process takes no time. Okay, so I will have batteries inserted in the computer, they will be running, and if the battery is not sufficient for that computer to work, so I will insert a new battery, and I can use the battery of the other computer as well. But why should I use the other batteries of the computers that are that currently running? And note that batteries cannot be recharged. Okay, return the maximum time you can run an computer simultaneously. Okay, test case 1, you have two computers. Okay, in the first diagram you have two computers and batteries with 333. I will connect first battery and second battery to the zeroth battery and first battery to the computer. So at one time the battery will depreciate to 22. Okay, this 22 is a battery percentage, 22. And after that I will again run for it one more minute, and battery percentage will be 1 1. So drop by 1 1. If okay, let me just try to draw it and explain it. A, B, C. Sorry, they are only two computers. Let me, I want red pen. A computer, B computer, we have a battery with capacity 333. So first computer will connect to this battery, and second. Okay, at time 1, both batteries will depreciate and give time 1, both batteries will depreciate and they will have 1 minute pass, so the count will decrease by 1 2 2. Now I can run for it for another minute. Okay, t2, the battery count will be 1 1, and 3 3, this battery is not used. And for 3 t3, if I run again, the the two batteries will die out in 3. And this 3 battery I can put in any computer, but that will not be simultaneous. Okay, so let's see the another for the time 2, we run for the time 1. Okay, for t equal to 1, and for second minute we will swap the batteries of beat within the battery that is not used. So I will disconnect this battery and use it. So I will run for the another minute. I will run for T2. For the battery for A will be depreciate 1, this battery will be 2, and this battery will be 2. So because it is connected to B, and this middle battery is not connected to it. And let's see, and we are given to. So if I run for now if I run for the T3 with the without swapping for A, then it will only run for 3 minutes. Now I will swap battery 1 with the middle one. So I will get like 2 1 2, and I will run for T3. Then T3 will be, and the battery will depreciate 1 1. T3 it run for T3. Now at T4, whatever I do, I cannot run more than that, right? Without any, there is no possible swaps that will make the time go beyond 4. And I will run for T4, the batteries will decrease by 1, value will decrease by 1, and this battery is not used, so it will be same, say that. So I run successfully for 4 minutes. So this is the answer. First I connected battery 1 to A, battery to the second computer, and for the time 1 I ran it for 1 minute. Then battery count will be, battery percent will be 2 2 and 3, and at the T2 I will swap the third battery with the second. So battery percentage for 3 is B is 3, and battery percent for A is 2. So I will run for T2, and the decrease will be 1, decrease by 1, and decrease by 1, and the middle one is not used. At T3, okay, I can run again. The battery percentage before T3 I will swap the battery 1 with battery 2 that is not used. Okay, this is the connection, and we will move the 1 to the middle, it is not going to be used. And now we have 2 battery percent for 2 2, and we'll run for 1 minute. So battery percent will decrease by 1, and we will we are here at after T3 we have percentage of 1 1 1, and at max we can run 1 minute only. So we will get 4 minutes. Let's see another example. We have two computers, A and B. Let me change the color, pen's color, A and B. So we have 4 batteries, 1 2 3 4 with the count 1 1. We'll connect first battery 1 with A, battery 2 with B. Now now we will run for 1 minute. The battery percentage will be dropped by 1, and these batteries are not connected, last 2 batteries. And T2 we will swap this batteries with the each battery with a new each battery. So we will have at this stage before 2 we will have battery with 1 1, battery percent 1 1, and we have swapped with the corresponding battery. And we will run for T2. We will we can run at exactly 2 minutes, right? So we can run, answer is 2 minutes. If we try to simulate this process, like we have given values A1 A2 A3. So if we are n cells and n computers, we can run exactly min of the values of the we can run exactly min of the batteries, battery percentages, min of that. If we were given 1 2 3 computers, we can run exactly 1 minute. We can, because we don't have any extra batteries that we can swap. Okay, so when we have when we add another battery, so okay, we have first we had 3 batteries, again I add 4th battery. So what will I do? I will sort this so that I can get a minimum value, so that I can get the minimum value at the first. Assume 2 is the minimum value, and the a2 a3 are some values bigger than a2, a3 and a4. Now what I can do, when I will run for the min minus 1 time, okay, a1 minus 1, a1 minus 1 time, and I will swap it with a2. Then the a1 minus 1 time, and battery percentage of a1 will be dropped by minus 1. Sorry, okay, we will run a1 minus 1 time, a1 minus 1 time. So we will have percentage of battery has battery a1 has 1, and we will swap it a1 with a2, a2 a3 a4. This corresponding value also will drop by uh, a3 minus a1 plus 1, and a4 minus a1 plus 1. So I can again, if the values, and I will take the minimum of this, and we can run for that time. And after that we will swap the one battery with the time to, sorry, let me explain again. Now I need to swap these values again, now sort these values again, so that I get the minimum value. Okay. Now assume we have like one, we have percentage like 1 to 2, and we have battery 1. Okay, battery of 2 I will run for a minute, and battery percent will drop by 1 to 2, 1 1, and I cannot I cannot increase the runtime of this. We can have a better example, like let's go for 3 minutes, 4 minutes, 5 minutes. We have given a 2 battery, so I will 3 4 5 batteries, 3 4 5 and 2 and 1 battery. These are the extra batteries. First I will run for 1 minute. The battery percent will decrease by 1 2 sorry, now 3 and 4. What I will do, I will swap. Okay, I don't need to swap. And again I can run for 1 minute. 1 3 2 3. Now I will swap the first battery with the second. So swap it. Let's swap it. We are getting 1 1. We will get 2 2 and 3. And for time 3 we will run again. We will get 1 1 and 3. Okay, now I cannot get past this. I cannot swap and get more time. I can just at least run for 1 time, right? So this will percent out of 4 will be 0 0 and 2. We successfully ran for 4 minutes. But if we and at the time 2, if we did not swap, so we can run at exactly 3 minutes, because the configuration was like 1 2 3. We'll run this battery without swapping, and sorry, after T3 the battery percentage will be 0 1 and 2. So swapping gave us an advantage of 1 minute. Okay, now in the questions of time, searching the time, or to find the minimum time or the maximum time, we use binary search. Search. Okay. We have n computers, n plus surplus of batteries, n plus k size. These are the batteries. We will take the minimum k batteries out. We have n max batteries. We will give all these batteries to each computer, and we will answer a question. For a time t, does it uh, does it for time t, let's assume time t, can it run for time exactly t, for at t or at least t? So we will check the count. If the battery percentage is less, so okay, x, we assume battery percentage x. If battery percentage is less than t, what we can do, we will run for x minutes and we will give the one battery to it. Okay, one battery to it, so it can run for x plus 1 minutes, uh, x plus 1 minutes, or we will try to make sure that this value x should run at least x time, at least t times. So if the k values can be summed to t minus x, so we will give a battery with the sum of this t minus x, so that will at least run for t. Okay, now we make sure that battery x run for t time, and we need to make sure for the other batteries to as well to run, so they run at least t time. Okay, and we will treat all the surplus batteries with if surplus battery that they have surplus battery to, we will map the surplus batteries to cell of 1 unit, 1 unit. This will give us an advantage. If we have k batteries with some 3, we will treat each battery percentage has a single 3 batteries. 3 batteries, we have one quantity. If if for a computer with a battery x, if it's falling behind, we will give we will try to make it run t minutes and t minutes. We'll give these batteries to the x battery, and we'll try to run it at least this k this for t plus k, x plus 3 minutes. Okay, I think I'm failing to explain, and because I don't have any intuition for how we are going to divide it, why is the batteries are treated as a single unit, as a single unit. Okay. Mm, okay, let's assume we have a battery with two units and 3 units. According to me, I will treat this battery as a single cells of 1 units. 1 I have 5 units of 1 3 4 5 units of batteries with a single percentage. If I have 3 4 and 6, what will I do? uh, I will ask for time 4. Can they run? For t3 cannot be run, so I need a battery of 4. I need a one battery, I will give it to it 4 4 6, then it can run. And again let me ask for 6, t6. So this is falling behind, so third cell cannot be run for it can run exactly 3 minutes, but for to increase I will give 1 cell 1 unit to it. So this will be increased by 6 3 no, it will increase the so I need to increase by 3, right, to make it at least 6. So it is 6. I gave it plus 3 battery. 4, I need 2 more batteries. I will give this 2 6 and 6, and this battery I have not given anything to it, so these batteries can run. uh, why does it give us an answer? Okay, let's try to understand that. I'm trying to understand. I saw the discussion section, and some guy just wrote the whole algorithm, just the important hint for the problem, treating the batteries as a single unit. It is the important pivot for it to solve it. Without it I don't think I can solve it. So uh, okay, now assume that we don't have this single units, we have not mapped it to a single unit batteries. So I will run for a minute. So the battery percent will drop by 1, 2 and 5. I will swap okay, I will swap the third battery and second battery with the first two small values. 2 and 3 we have given 2 and 5, 2 and 2 and 5. We'll run for another minute. Decrease by 3, decrease by 2, decrease by 4, decrease by 1. I decrease by 1. So this is swap. This is one run. This is second run. And I will run again 3, 0, 1 and 3. And I will swap the this cells with 2, 2. Then 2, 2, 3. This was the swap. At T4 I can run 1, 1 and I can at T4 we can run again 3. We are giving batteries 1, 1. We are left with 1, 1. So again I will run 5 minutes. 0, 0, 4, 2. And I can swap these batteries the 0, 0 batteries with 1, 1. I will get a 1, 1, 2. So and for 6 minutes I will again run it 0, 0, 1. And I cannot run for another minute because we have no batteries left with powers. So I ran it for 6 minutes. Let's try to code it, and I will try to understand after the stream by the treating the batteries as a single units works. Okay, I think small cases we can discuss it. We have given and batteries enter k equal to batteries dot size dot length, and we are going to sort batteries. Arrays dot sort the k batteries. K batteries array batteries. Okay, and we will sum all the surplus batteries and treat it as a single battery. So enter sum with these are the extra, these are cell with 1, cell 1 equal to 0, and for int we will take all the small k batteries, no not k batteries, n minus k, n minus k and minus 1. I plus plus I should be less than equal to k minus, I is less than equal to k minus 1. Sum those values. Say cell 1 less equal to batteries of 5, batteries of 5. If this single units are no are 0, then we cannot run them run we cannot run it for the extra time. We had we are not we have no any surplus batteries. So what we can do, we can just return batteries of 0, 0. So it will run at exactly batteries of 0 minutes, the first value of that is the minimum time. Let's take the lower, we are searching for, okay, we need to convert this to long. By default it is an integer, and we need to take the cell battery as size as long. Okay, now assume, now we need a lower bound. The not possible value for the lower bound is -1, and high, we need to think about it. Let's see the constraints. Battery size can be 10 power 9, and batteries, okay, batteries can range up to 10 power 9, and batteries can batteries dot length can range to 10 to the power 5, and computers can also. To find the highest bond, we will lower the n. It has only one cell, and we are given 10 to the power 10 to the power 9 batteries of length 10 to the power 5. That will give us 10 to the power 9 into 10 to the power 4, 10 to the power 5. That will result in 10 to the power 14. Yeah, 10 to the power 14, right? Long 1e4, long 1e14, 14 plus some extra values 999, and we'll write our binary search algorithm as greater than low plus 1, and at the end we will return high pointer. That will be the answer to our problem. To calculate mid time, for okay, it can be time is long, can be long, right? Mid equal to low plus high minus low by 2. Now we need to run for this mid time, right? We'll start the from the okay okay okay, we need some variables like current time equal to 0 minutes, and at the end we need current time to be greater than equal to mid. Then we can say that we can run for at least this minutes, else high equal to mid we cannot run it for mid time. And we will run our algorithm from I int I equal to from the we left n minus k minus 1 batteries, so we will run from n minus 1 to I is greater than I is less than k, I plus plus. And we need another variable long, uh, the time we need extra batteries we need extra time to need 0. Now assume that now and from the first battery nth battery is attached to the computer, and we will make sure that this battery will last for at least mid time. So we'll first what is the current time? Current time will be current equal to current time of this will be batteries of I plus we need extra, right? For extra, what we can do, okay, if this batteries of I is less than time, we need to increase it by how much? By extra plus equal to math dot absolute value of uh, mid minus battery I. Okay, so the extra time will tell us this battery should be increased by that amount mid minus batteries. So, and we will make the to make the this algorithm more faster, we can write this that extra time is less than equal to the less than equal to the okay, we will not optimize it because okay, now we'll assume that now if we iterate for the whole minute, and we make sure that extra batteries, and we will make sure that extra is less than equal to cell size, the cells of 1. These are the extra amount, and I forgot and we'll make sure we return the low. uh, we're going to return low because we are taking low as our answer. Extra is less than equal to CELL. Okay, I made a typo here. Cell of 1, not cell of I. Cell of 1, low equal to mid, I equal to f battery n minus 1 to k. I ran it for k. And let's check the formula, is it correct? We had iterating per n minus k, n minus k, n minus k to k, right? The difference will give us n, so I need to fix it. Okay, n minus k, n is greater than k, right? Okay, current time, I don't need this current time, right? Current time will, we are making sure that the extra time we need, we are increasing the extra time, telling us that we need surplus this quantity mid minus battery of I to be surplus. We need those single cells for it. Is equal to cell of 1, and this cell of 1 equal to 0, battery we are returning batteries. That is look good. And long, that's work. Okay, we're subtracting mid minus battery of I, that is also long value. That will also give us a good correct answer. Okay, n minus 1, cell of 1, increasing the battery's potential. Okay, okay, I think this should run, right? Oh, why didn't it run, bro? Why? We can run. 333, so we are given 2, so 3 minus 2 is 1, n minus 1 minus okay, 3 minus increasing by 3, 0. Test case, okay, and batteries is k equal to 3, 3 minus 2 is 1, 1 minus 1 is 0, so we'll keep the third battery has a cell at 3. So n minus k minus 1, so is 3 minus 3 is 0, like that will run. Can I use this statement here? What can I do here? I can print that, is it this statement going to execute? Ellen, I'm here, so telling me that this if statement is going to execute, and we don't have many cases, many ifs. Okay, it got it entered into if condition. Why did it do it? N is 3, n is 2. Okay, n is okay, n is 2. Okay, so that's why if where k is greater, right? K minus n, we'll need to make here also change. K minus n, k should be greater than, right? K minus n, this will run. Okay, this is correct. We'll submit it. Oh, why? What did we do wrong here? We sort it, okay, and we had 3 cells and we gave 10, 10, 5. It didn't run for at least 0 minutes also. Why is that? N minus k, I is less k minus 1, okay, 3. 4 minus 3, we got a 3. Uh, let's try run here, right? For the first loop, uh, what will be the cell of I? It will run for, we have 4 values, 4 minus 3 minus 1 equal to 0. So it will store the minimum value of the current array 3. Now from 3 came 4 minus 3 and we are here. I will start from 4 minus 3, it's 1. Okay, we will run for 1 for the extra time. Well, subtract minus my mid minus batteries of I. Okay, this will tell us the extra time, right? Okay, if okay, we don't need absolute value. It is a blunder. Math dot minimum minimum of 0, yeah. Okay, because batteries, if the time is less than the battery percentage, this will give us a negative, but we are adding it to the extra, that will give us an wrong value. Oh, why? Okay, max. Okay, sorry, max. uh, why I'm so noob? Okay, we got it. We are under the time. Let's run it. Okay, we got it right. We have done it successfully. We can improve it, right? What can I do? I will make the declaration of k minus n to be outside. So and I need to make sure that extra time is less than equal to time to the cell size, extra cells, surplus cells. And I need to make sure that we have taken care of the all the cells. Okay, sorry, we need to control Z नहीं हो रहा. Okay, now I equal to k and so this tell us when we are taken all accounted for all the batteries, and the extra cells should be less than equal to cell of I. This will give us a good this will optimize it for the uh, cell of I, not cell of 1, cell of. Okay, this will give us a lower bound, I think. Low. Yeah, I didn't improve our complexity that much runtime. The submissions are, let me check my submissions. Okay, did it improve by 3 2 ms. 2 ms we did it in less 2 ms. Okay, that's it for now. Should we stop here or? I need to fill the form. Okay, I will back. I will back after some time.